Let's move on to subdivision 9. The series goes like this: 1, 3, 9, 27 and so on. So let's find the difference. So D equals A2 minus A1 for the first two terms. So this is 3 minus 1, which is equal to 2. Now D equals A3 minus A2 for the next two terms. So this is 9 minus 3, which is equal to 6. Now clearly the difference is not the same. So this is not an AP. So we can say, since the difference between the successive terms are not the same, it is not an AP. Let's do subdivision 10. This is A, 2A, 3A, 4A and so on. So as usual, we'll find the difference between the successive terms. Let's take the first two terms. So D equals A2 minus A1. This is 2A minus A, which is equal to A. Similarly, D equals A3 minus A2 for the next two terms. This is 3A minus 2A, which is equal to A. And similarly, D equals A4 minus A3 for the next two terms. So this is 4A minus 3A. Again, this is A. So clearly the difference is same for the successive terms, or common difference equals A. So D equals A, since the difference between successive terms are the same, it is an AP. Now how do we get the next three terms? So this is A5 equals A4 plus D, 4A plus A equals 5A. Similarly, A6 equals A5 plus D, which is equal to 5A plus A equals 6A. Similarly, A7 equals A6 plus D, which is 6A plus A equals 7A. We have A5 equals 5A, A6 equals 6A, and A7 equals 7A. So how this series will go on? So this will be 5A, 6A, 7A, and so on. Now let's do subdivision 11. The series goes like this: A squared, A cubed, A power 4 and so on. So let's find the difference for the first two terms. D equals A2 minus A1, which is equal to A squared minus A. Now similarly, we'll find the difference for the next two terms. D equals A3 minus A2, which is equal to A cube minus A squared. Similarly, D equals A4 minus A3 for the next two terms, which is A power 4 minus A cubed. Clearly, the difference is not the same. So this is not an AP. So we can conclude like this: since the difference between the successive terms are not the same, it is not an AP. Let's do subdivision 12. The series is root 2, root 8, root 18, root 32 and so on. So as usual, we'll find the difference. D equals A2 minus A1 for the first two terms. This is root 8 minus root 2, and root 8 can be written as square root of 8 equals square root of 4 into 2, which is equal to 2 root 2. So using this, we can write this as 2 root 2 minus root 2, which is equal to root 2. Similarly, D equals A3 minus A2 for the next two terms. This is root 18 minus root 8. Again, this is 3 root 2 minus 2 root 2. And how did we get this? Root 18 equals square root of 9 times 2, which is equal to 3 root 2. So this will be 3 root 2 minus 2 root 2 is root 2. Similarly, D equals A4 minus A3, which is equal to root 32 minus root 18, which is 4 root 2 minus 3 root 2. And how did we get 4 root 2? This is square root of 32 equals square root of 16 into 2, and this is 4 root 2. So this is equal to root 2. Now clearly the common difference is root 2, and we can say, since the difference between the successive terms are the same, it is an AP. So how can we get the following terms? A5 equals A4 plus D, which is equal to root 32 plus root 2. This is 4 root 2 plus root 2, which is equal to 5 root 2, or root 50. Square root of 50 equals square root of 25 times 2, which is equal to 5 root 2. A6 equals A5 plus D, which is 5 root 2 plus root 2, which is equal to 6 root 2, and this is square root of 72. So again, square root of 72 equals square root of 36 times 2, this is equal to 6 root 2. And A7 equals A6 plus D, which is equal to 6 root 2 plus root 2, which is equal to 7 root 2, and this is equal to root 98. So how did we get this? Square root of 98 equals square root of 49 times 2, which is equal to 7 root 2. So we know the next three terms, and we can write them. Root 50 comma root 72 comma root 98. Let's do the next one, subdivision 13. The series is root 3, root 6, root 9, root 12, and so on. So let's find the difference. D equals A2 minus A1 for the first two terms. This is root 6 minus root 3. Similarly, D equals A3 minus A2 for the next two terms, which is root 9 minus root 6. This is 3 minus root 6. Now clearly the difference is not the same, so this is not an AP, so we can conclude the problem. Since the difference between the successive terms are not the same, it is not an AP. Now let's do subdivision 14. The series is 1 squared, 3 squared, 5 squared, 7 squared, and so on. So we'll find D for the first two terms. This is A2 minus A1. And what is A2? 3 squared. We can write it as 9 minus 1 square is 1. So this is 8. Similarly, D equals A3 minus A2 for the next two terms. So this is 25 minus 9, which is equal to 16. Now clearly the difference is not the same, so we can conclude the problem that this is not an AP. So as usual, we'll conclude, since the difference between the successive terms are not the same, it is not an AP. Now let's do subdivision 15. The series is 1 squared, 5 squared, 7 squared, 73, and so on. So as usual, we'll start with finding the difference between the successive terms. So we'll start with D equals A2 minus A1, first two terms. So this is 5 squared minus 1 squared. This is 25 minus 1 equals 24. D equals A3 minus A2 for the next two terms. This is 7 squared is 49, 49 minus 25, this is equal to 24. D equals A4 minus A3 for the next two terms, which is 73 minus 49. Again 73 minus 49 equals 24. So the difference is same, which is equal to 24, and therefore this is an AP. So we can write, since the difference between the successive terms are the same, it's an AP. Now we have to find the next three terms. So what is A5? A5 equals A4 plus D, and this is 73 plus 24, which is equal to 97. Similarly, A6 equals A5 plus D, which is 97 plus 24, which is equal to 121. So therefore A6 is 121 and A7 equals A6 plus D, which is equal to 121 plus 24, and this is 145. So these are the next three terms, and we can complete the series, or we can write the next three terms of the series. 97, 121 we can write it as 11 square because some of the terms are represented as squares. So we can write 121 as 11 squared and 145, so on.